Okay, so the main connection between what we've been doing the last couple weeks is we started off with section 1.9 way back in the textbook because that was on inverse functions. Then we jumped to chapter 3 where we just talked about exponential functions. And the point of that connection is that exponential functions and logarithmic functions are inverses of each other. So you will be asked, and you need to know, that something like log base 3 of x and 3 to the x power are inverses of each other. Log base 3 of x is the inverse of 3 to the x, and 3 to the x is the inverse of log base 3 to the x. Okay. Also, log base 8 of x and 8 to the x, those are inverses of each other. So you'll be asked questions like, what's the inverse of 5 to the x? So that would be log base 5 of x. And then to go the other way, you should know the inverse of log base 2 to the x is just 2 to the x. So you need to see that connection. You need to be able to say what his inverse is. Now, how that's going to help us with logarithmic graphs, and the whole point of our last couple weeks of planning, is because if I just asked you to graph number 5, you probably wouldn't have any way to do that. Maybe if you could find the buttons on the calculator, you might have a clue on how to get it started. But if I asked you to graph 2 to the x, that one should be okay. 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. 2 to the negative 1 is a half. That you should be pretty familiar with now. Well, if you really understand what inverse functions are, then you can take this information about 2 to the x and use it to graph log base 2 to the x. Because inverse functions, you're just switching x and y. So if a function has a point at 0, 1, its inverse is going to have a point at 1, 0. Switch x and y. If its function has a point at 1, 2, then its inverse is going to have a point at 2, 1. 2, 4 becomes 4, 2. Negative 1, 1/2 would become 1/2, negative 1. And of course you can plot more and more points. The more points you do, the quicker you're going to see it. But this is what log base 2 of x looks like. Now fortunately, just like 2 to the x and 3 to the x and 5 to the x and e to the x, and all of those functions look very, very similar. They're all exponential growths that look basically the same. That means with logarithms, those graphs end up looking the same as well. Log base 2 to the x is going to look a lot like log base 3 to the x, a lot like log base 5 to the x. It's got a similar shape. So if you looked in a math textbook, it would probably call this a parent function, meaning you should see it enough that you might want to memorize it. But you should always be able to discover it this way. If you understand that these are inverses, you can get some points for the function, switch x and y because that's what it means for inverse. Then you can always get some points for your inverse graph. Now of course that's a pretty plain graph, that's just the parent function, so we do like to make some transformations. Now all the same transformation rules apply. If you add to 3, that's just going to shift the whole thing left 3. So etc. Shifting up and down the same, reflections are the same, everything's the same. But if you had only asked me to graph h of x, I probably would still graph those first two graphs. I'd probably still graph 2 to the x, switch all the points to get log base 2 to the x, and then I'd take log base 2 to the x, and then I'd shift it left 3. before I ended up with the one that you might actually be interested in. So to emphasize that, question 7 is a much more complex graph. Negative log base 3 of x plus 5 minus 1. So that seems kind of intimidating. But again, you need to understand, I mean, it's going to take a little bit of practice. I'm not asking you to get to practice today, but you need to see what your path should be to figure out what this graph looks like. And all of this, the parent function is going to be log base 3 of x. Until you know what that looks like, you might say, well, I know what 3 to the x looks like. 3 to the 0, 3 to the first, 3 squared. That's what 3 to the x looks like. That helps me figure out what log base 3 to the x looks like because they're inverses. Switch x and y, switch x and y, switch x and y. So to me, knowing what 3 to the x looks like is kind of a tool to help me know what the logarithm graph looks like. Now I'll worry about the transformations. If I plug the number in for x, the first thing I have is plus 5, so that would shift it left 5. So take some of these points that you found, count left 5. Okay, so now I know what log base 3 of x plus 5 looks like. I don't need the parent function anymore. Looks like the next transformation would be this negative 1, which we know flips it over the x-axis. So it's already on the x-axis, it stays on the x-axis, but this point would flip down, that point would flip down. Guess that's about all I got there. Okay, looks like I flipped it over the x-axis okay, so I'm going to erase my previous step. This now represents log base 3 of x, but I shifted it left 5 and I've reflected it over the x-axis. Looks like the last thing it's asking for is this minus 1, so we should know that that means it goes down 1. So take all my points, shift them down 1. Don't need that from before. And now this is the function I. So it takes a minute, but since it's the same transformation rules that we have, the only hurdle you should have is maybe knowing what log base 3 of x looks like. So graph 3 to the x and understand that it's the inverse, so you can just switch the x and the y in all the points. Then you've got the parent function, then you can do whatever transformations that it's asking. Okay, so then within that, we will ask a few questions like domain and range, sometimes intercepts, sometimes asymptotes, stuff like that. So domains asking you to describe the x values that it hits. So that looks like from negative 5 that it doesn't reach, because it doesn't actually reach negative 5, forever to the right. To find the x-intercept, if we just needed an estimate, or maybe if it's multiple choice, we could see that it's somewhere between negative 4 and negative 5. Most of the time we need to be more accurate than that. So what we will do is x-intercepts always have a y value of 0. So we'll plug in 0 for that, and we will solve that for x. We're just not going to do that today because I haven't told you how to evaluate a logarithm yet. That'll be something for next week. But it's the same way we found y-intercepts in section 3.1. Y-intercepts, we plugged in 0 for x. Now we're saying to find x-intercepts, plug in 0 for y. And then once you know how to evaluate that, then you would need to finish it. And then finally, our exponential graphs had horizontal asymptotes but not vertical asymptotes. So now that we're talking about its inverse and we're switching x and y, now they're going to have vertical asymptotes and not horizontal asymptotes. So that would be right here. The x value that it gets closer and closer to but doesn't get to actually touch or cross. And since it's a vertical line, your equation should be x equals. Horizontal lines are y equals. But with our graph, we just have to look at it, and then it should be there for us to extract that information from. So I'm not concerned about you with the transformation rules, although of course if you know you mix those up sometimes, then you definitely need to study those. You should know what domain, x-intercept, and vertical asymptote are asking for. It really comes down to, can you get the graphs looking correct? And so the most important part by far to really connect the last couple weeks is you need to understand how these are connected, and you need to understand that inverse functions just means you're switching x and y. So xy becomes yx, and then that gets us some points and allows us to visualize now what a logarithm graph looks like. Okay, any quick questions that stand out? Your question doesn't have to be quick, but nope. Okay.